हेलो एवरीवन, वेलकम टू स्टडी एरा। जैसा कि आपको पता है कि वी हैव स्टार्टेड अ न्यू शॉर्ट वीडियो सीरीज इन विच वी विल डिस्कस द स्मॉल टॉपिक्स ऑफ सिविल इंजीनियरिंग. In this video, we will cover the topic acceleration of fluid particle. It is from fluid kinematics. So let's start. In acceleration of fluid particle, the first one to be considered is Cartesian coordinates. In Cartesian coordinates, we give velocity as I cap u plus j cap v plus k cap w. Now, as we know that acceleration is nothing but change in velocity. So we will write ax is equal to del u divided by del t plus u dot del u divided by del x plus v dot del u divided by del y plus w dot del u divided by del z. Similarly, we can write ay and az. Now in this acceleration value, the value of del u divided by del t is nothing but temporal acceleration, or del v divided by del t is temporal acceleration, or del w divided by del t is. So, and the rest of the term is nothing but convective acceleration. Now, we will study about the local acceleration, or it is also known as temporal acceleration. The value of delta u divided by delta t is equal to the local acceleration, or del v divided by del t or del w divided by del t is equal to local acceleration. That is, the change of speed with respect to time only is known as the local acceleration. So, and here it is written as in steady flow local acceleration is 0. As we know that in steady flow the quantity with respect to time does not change, hence del v divided by del t is equal to 0, hence local acceleration is 0. The second one is convective acceleration. Convective acceleration represents the rate of increase of velocity due to particles change of position. Assume that a particle is there in a fluid, and if the position of that particle is changed, and due to that change of position of particle, there will be an acceleration. So that acceleration is known as convective acceleration, and it is given as a convective is equal to vs bracket del vs divided by del s. And as it denotes that it's now as it denotes as the change in space, so in uniform flow the convective acceleration becomes 0. Hence there is a important note: in steady flow the local acceleration is 0, but the convective acceleration is not necessarily 0, and hence total acceleration is not necessarily 0. However, if flow is uniform also, convective acceleration is 0, and therefore total acceleration is 0. I hope this is clear. The next type of acceleration is tangential total acceleration. The tangential total acceleration is given as as equals to del vs divided by del t plus vs del vs divided by del s, and the normal total acceleration is an is equal to del vn divided by del t plus v square by r. Here this thing need to be remembered, it is v square divided by r. Now r is equal to radius of curvature of streamline, vs is the tangential component of velocity. Here its vs is equal to tangential component of velocity, and vn is equal to normal component of velocity. Now del vs divided by del t is the local tangential acceleration, and del vn divided by del t is local normal acceleration. Now subsequently the next term is tangential convective acceleration, and v square by r is equal to normal convective acceleration. There is one more acceleration type, which is acceleration in polar coordinates. So in two-dimensional polar coordinates, acceleration is given as del vr divided by del t plus del vr divided by del r plus v theta divided by r del vr divided by del theta minus v theta square divided by r. This formula is quite typical, but you have to remember this. A theta is equal to del v theta divided by del t, and so on. Now hence this video is completed. Thank you so much guys for this much love. Please like, share and subscribe the channel. Thank you.